Now it's your turn to practice evaluating expressions that involve higher order roots. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this video, we're going to evaluate expressions that have higher order radicals. So we can see in this first example, we have a fourth root. In the second example, we have a fifth root. And in the third example, we have a third root. So for this first one, we're looking at the fourth root of the number 81. To evaluate this, what we're looking for is to see what number, when raised to the fourth power, gives us 81. So we're essentially doing the opposite of raising a number to the fourth power by taking its fourth root. So a couple side notes that we'll start with is what number gives 81 when raised to the fourth power. So what we're thinking about here is that some number, which we don't know, and I'm going to use as a question mark, raised to the fourth power is going to give us 81. Because numbers raised to the fourth power tend to be really large, there aren't that many numbers that are possible to be the fourth root of 81. So let's look at making a quick table. 0 to the fourth is going to give us 0. 1 to the fourth will simply give us 1. 2 to the fourth, that's 2 times 2 times 2 times 2 is going to be 16. And 3 to the fourth power is going to be 3 times 3, which is 9, times 3, which is 27, times another 3, which is going to give us 81. So the fourth root of 81 is going to be 3. The last way that we can look at breaking this down is to turn this into the fourth root of 3 to the fourth. And so the fourth root of 3 to the fourth is simply the number 3. Looking at our next example, we'll take a similar approach. I'll go a little quicker with this one and won't do quite all the background work. But the fifth root of 32, we're thinking, what number, when raised to the fifth, is going to give us 32? So I've written this as question mark number raised to the fifth is going to give us 32. So again, looking at fifth roots, I know that 0 to the fifth is 0. I know that 1 to the fifth is simply 1. 2 to the fifth power is going to give me 32. And so I know then that the fifth root of 32 will just be the number 2. So I can rewrite this fifth root of 32 as the fifth root of 2 to the fifth, and that's simply the number 2. This last example is the cube root of 0. Now, if you've noticed in each of these others, anytime I take 0 and raise it to some positive integer power, I just get 0. So, because 0 cubed is 0, the cube root of 0 is simply going to be 0.